All right, hello and welcome to problem 6.9. We have a skier skiing down a slope and we're trying to find the acceleration. All right, first of all, we know that acceleration is equal to the net force over mass. So we need to find the net force. In order to find the net force, we need to make a free body diagram. So this problem, we know we're going to have to tip the axis to be parallel with the slope. We tip the axis to be parallel with the slope. All right, and that just makes the math a whole lot easier down the road. You could do it without doing that, but good luck. It's pretty tough. All right, so looking at this object, this guy skiing down the hill, we can tell that gravity is pulling him straight down. All right. We know that friction is resisting him backwards. We know this hill is having a normal force upwards. Force of friction, force of gravity. All right, and that's it. Those are the only forces on this guy. All right, so nothing too crazy here. So looking at this problem, we draw a free body diagram. So here's the guy. He has a force backwards, which is the force of kinetic friction as he's sliding. We have a force downward, which is the force of gravity. And then we have the normal force, which is going upward. First thing I like to do is I like to make the components of the force of gravity. All right, so the force of gravity, make a right triangle with the y-axis, and then a right triangle with the x-axis. All right, and then you have your x component of gravity and your y component of gravity. So we'll call this F, force of gravity that's in the new y direction, and force of gravity that's in the new x direction. So there we have it. We now have 1, 2, 3, 4 forces in this problem. So we're looking for the net force. Now we know that net force will be in the x direction because he's sliding downhill. So there will be a net force going downhill. There will be no net force going up because it's all canceled out. Okay, net force will be going downhill. All right, so let's start with the sum of forces in the x direction, since that will be the sum of forces direction anyways. So we have a coefficient of 0.3, a mass of 76, and an angle of 37. All right, so let's take a look at this problem. We're going to do a sum of forces in the x direction. All right, in this problem, green is going to represent known forces, and red will represent unknown forces. So the sum of forces in the x direction is going to be unknown, and it's not going to equal 0, but it is going to equal the force of kinetic friction, which right now is unknown, force of kinetic friction, minus the force of gravity in the x direction, which will be known. So continuing this out, we have the force of kinetic friction, which is equal to the normal force times the coefficient of kinetic friction, minus the force of gravity in the x direction, which is equal to Fg times the sine of theta. Now let's explain that. Okay, the sine of theta, well, the angle that we're measuring from is right here. Okay, so Fgx is going to be the opposite of that angle, therefore we use sine. All right, so now in this problem, we know everything. Okay, we know the coefficient of friction. So we know everything except for the normal force. Therefore, we need to solve for the normal force. Well, to do that, we need to go to the net force in the y direction to do that. We know that the net force in the y direction is equal to 0 because the guy is not accelerating vertically. And it's equal to the normal force minus the force of gravity in the y direction. And that force is known, so it should not be read. Minus the force of gravity in the y direction. Continuing this out, we have 0 equals our normal force minus Fgy is equal to, it's equal to Fg times the, not the sine, but the cosine of theta. Therefore, the normal force is now known. The normal force is now equal to Fg times the cosine of theta. It's known, okay, because the force of gravity is known, theta is known, everything's known now. So what we can do is we can take all of this and plug it in for the normal force right here. That's exactly what we're going to do. So when we do that, we end up getting Fg times the cosine of theta times mu kinetic friction minus Fg times the sine of theta. All right, and that, that is it. Okay, that's the equation to find your answer. Now we just would have to plug things in if we wanted to actually solve it. Get this stuff out of the way. All right, so actually solving this problem real quick, we'll take it one step further. And Fg is going to equal mg. Okay, we know his mass, we know his gravity, times the cosine of the angle, which was known, times the coefficient of friction, which was known, minus the force of gravity, which is mg, times the sine of theta. All right, plug all that into your calculator and you'll get a final answer for your net force. Simply divide that by mass and you have his acceleration. And that is all you have to do.